shortly. Dear Girish, request you to also play the membership video.
Sure, sure.
Thank you. Once again, a very warm welcome to all the participants who've joined us this evening. We truly hope that you're all safe and sound. Our best regards from Mr. Bangalore chapter. Today's session is going to be on the latest technology on conventional UPS and choosing right modular UPS for critical loads by Mr. Ashok Kumar. Mr. Ashok Kumar has completed his engineering in ENC and has a post graduation in sales and marketing. He's currently working as the country head UPS division of ABB India Limited from the past 11 years. He's also responsible for the UPS sales in Bangladesh and Sri Lanka. He has an overall experience of 25 years in the UPS industry. We would like to thank Mr. Ashok for doing this session for us at ISHRE Bangalore chapter today. Over to you, sir. Mr. Ashok, you're on mute. If you could unmute, yes, yeah.
Yeah, thanks, Nisha. Thank you so much, and warm welcome to this event. And firstly, I would like to thank Ajay Bararia and ISRE Bangalore chapter, and as does ISRE Bangalore chapter for organizing this event. Myself, Ashok, and right now I'm working in ABB as a UPS product marketing and sales. Just I would like to share my screens. Just confirm once you can able to see the screen.
Yes, sir, it's visible.
Yeah. Anyway, I'll take it up very quickly because the time is very limited. Just I would like to highlight the main important points, the technical points on the conventional and as well as the modular UPS systems. I saw that the video clippings really it's wonderful, and we all are now moving towards the energy efficient world. Certainly, the UPS will contribute much on this. Okay. And this is the, you can see the various types of UPS here, the various types of UPS systems here. There are multiple models, technology, multiple technology, okay? Conventional UPS technology, modular UPS technology, okay? The conventional UPS technology earlier 2 decades was totally different. 2 decades was totally different. And now the technology is totally, it's a different. We are moving towards a fantastic technology where we can save huge money on account of energy savings. That is the main topic here. As well, the modular UPS, there are many technologies available in the market. And what is the right model for the critical loads? That I'll touch upon those topics 2 or 3 slides. And maybe during the end of sessions, if you have any questions, you can write. And the UPS meant for all the applications. UPS, you can see the various pictures in the down, data centers, as well as the now most of the pictures are data centers, as well as it is going to be a industrial application also. Okay. To start up with the UPS, it start the single phase UPS. The single phase UPS also available in the market. It starts from 600 VA, 600 VA to 10 kVA. It goes to the applications like IT rooms and building infrastructure and ATMs. Double conversion UPS. This is the major one. Now, how the double conversion is? The double conversion is happens from grid supply to UPS. I mean, it's converting from AC to DC and DC to AC. That's the main reason it's called for a double conversion. It's purely meant for critical applications. It's totally isolated. It's a double conversion UPS systems. The double conversion UPS systems available in the market is from 10 kVA and above. From 10 kVA to can go up to 5 megawatt UPS. And another one is a modular UPS. The modular UPS, here the rate stands from 10 kilowatt and above. There are some technologies available, certainly. There are some 5 kilowatt also it's available. Here, the solution available up to 3 megawatt. Modular UPS meant for critical applications as well as scalability. Scalability, as and when required, we can upgrade the UPS capacity instead of going for the higher capacity from the day one. That is the main concept for going for a modular UPS. Now, say just for example, the current load is say 200 kVA, and it may go up in future, say 300 or 400 kVA UPS. In conventional UPS, here the conventional UPS, they are going for the UPS systems to higher capacity from the day one, considering the future expansion. So here the main block is capex investment. The capex has been blocked from the day one, even though the load is only 100 kilowatt or 200 kilowatt. Where in the modular UPS systems, the load is 200 kilowatt, go with the frame of 400 kilowatt, and as and when required, you can increase the UPS capacity. That's called the scalability. And another one is serviceability will be easier. That I'll brief it to you how it is going to be. And single conversion, this is the new, it's eye-opening. I would say the single conversion UPS also available in the world now. Okay, in India, maybe it may take some time, but it's available. It's a single conversion UPS systems. It's a medium voltage UPS. It's not a low voltage UPS system. It's a medium voltage UPS systems. It meant for, again, all the critical applications. So coming to the conventional UPS systems, the picture it is showing, it is a 60 kVA and above. Here you can find it is around, your eyebrow may be rising. Here you can see that the rating, it's in kilowatt, not in the kVA. That is the main thing is here. You can see most of the technology is designed for a kVA. In the sense, the output power factor of the UPS systems, it may be a 0.8 or 0.9 or sometimes 1. So we have to be we have to give some attention to this point. What is that input power factor? It is a most of the technology, its input power factor is unity. It's a better power factor, no doubt on it. But when it comes to the output power factor, that is where the small it's a challenge. Some of the technologies are 0.8, some of the technology is 0.9, and some of the technology is unity. How customer is going to get benefit out of it? If output power factor is designed for a 0.8, 100 kVA can support only 80 kilowatt load. If it is designed for a 0.9, it can support a 90 kilowatt load. Designed for a 1, it is a 100 kilowatt. It's a 100% power, 100% value for money. Now, this is the latest technology in conventional UPS systems. We need to ask that what is the output power factor of the UPS systems, not the input power factor. Output power factor, if it is a unity, that's a better technology, because now most of the IT loads, it is designed for a unity power factor. 2 decades back, yes, the loads are designed for a 0.8, so absolutely not a problem. Now what happened, all the loads are designed for a better power factor, 0.9 plus. And why we need to degrade on this? So let us move towards a better technology. That's a unity output power factor. So this is the multiple capacity here. The picture what it is showing, 60, 80, 100, 120 kilowatt, and it's 500 kilowatt. The technology available in the market, even 600 kilowatt also it's available. And the maximum 10 units can be paralleled here. Now, and in 500 kilowatt, 10 units paralleling, it can give a solution up to 5 megawatt. The technical aspects, it's going to be remain same for from 60 to 600 kilowatt. And so since the time very limited time, I do not want to go for each rating wise. The technical aspects remain same. The picture what it is showing is a 60 to 120 kilowatt. The efficiency, this technology, say when it's coming to the kilowatt, the technology, the efficiency is better. The power loss, the heat loss is very less. It is a 96% efficiency and a compact footprint. Without transformer, this is even transformers may not require for this kind of unity output power factor UPS systems, because it's having an inbuilt technology of EDCP, that's called the electronic DC protection filter inside. There is no need of transformer. So now without transformer, there are multiple there are technologies available where it can give a better performance and better efficiency. And the rectifier side, I saw that you may be aware that there are two type of rectifiers. One is IGBT rectifier and another one is a thyristor based rectifier. Thyristor based rectifier, it's a old technology where it comes with efficiency of 93% and harmonics may be very high. And later it is working with IGBT. IGBT rectifier is a unity input, it drives with unity, and as well as the harmonics has been very much subsidized. And now the technology, there are additional advanced technologies, diode with IGBT. That's the main topology now, diode with IGBT, where in this diode with IGBT, the harmonics will be further less. Input current harmonics will be a further less when we are using a diode with IGBT in the rectifier side. So we need to specific about what type of rectifier it is, whether it is a thyristor based rectifier or IGBT based rectifier or any other hybrid technology. So the diode with IGBT is hybrid, it's a rectifier it is. Here one is that it's very much controlling the current harmonic, as well any kind of phase reverse at the input side. Say generally the UPS systems work with RYB mode. If it's going to be a YBR or BYR, what will happen when we are using a polarity devices like a thyristor or IGBT? The rectifier will trip and it will go to the battery mode. Here what happened, the advanced technology is diode with IGBT. Even if any kind of phase reverse, system continuously to work, it will not go to the battery mode. That is the main advantages in this rectifier topology. And it gives the better efficiency. And efficiency in this technology 99% echo mode. Output power factor, this is need to specify again, it is a unity output power factor it is. We need to stress upon this unity output power factor. All the technologies available, that is, this technology is not available with only one supplier. All the manufacturers are having this output power factor. So unless we need to specify, I need only unity output power factor, we may not get it. So let us go towards the better technology. And the THDI will be a 3.5% since it is using a diode with IGBT. 10 units can be parallel to maximum. Integrated manual bypass and optional backfeed protection. Now manual bypass, static bypass, everything is built in the UPS systems. Nothing is additional. No need to worry about it. Everything has been put in the one box. And apart from that, we need to ask whether how the battery testing is going to be, whether it is going to be a manual or automatic. This both the options should be available. It is available already. It is there in the technology. The customer needs to ask, I need automatic battery test. Okay. So in this case, what happened? We need to program it just we need to program it on what interval battery needs to be checked without any service engineer interference. And it will check the battery conditions automatically during the time period, and it will give a report about the battery health conditions. And front service access, and most of now the space is the main constraint. Space is the main constraint. The unity output power factor UPS systems, all the components, all the critical components, I mean, that it be a semiconductors or fuse or breakers, whatever it is, it has been placed in the front side of the UPS systems. So what happened? If we are going for a multiple UPS systems, we don't need to consider additional space over here, the rear side. Rear side, we don't consider additional space. Otherwise, what happened? We need to consider 3 meters distance here. We have to consider the space over here for the service engineer access if we keep any kind of space over in the side or here. So, but where in this technology, this India Oku factor technology, all the component has been placed the front side of the UPS systems. So it's only the front service access is required for this topology. Additionally, flexible battery management. This is again another one very important parameters. Okay? Flexible battery management. We need to specify about how the battery management is. I mean, say now for example, if any UPS systems working with the 40 blocks of 12 volt, in the initial time, maybe the 2 to 3 years, absolutely not a problem. If batteries are it's a commodity, okay, and the 2 to 3 year systems will work fine. Battery will be fine. Maybe fourth year, there will be a 4 or 5 batteries will go bad. So in that conditions, what happened? It's a standard practice in the market, standard practice which we are following the last 2 decades. We are replacing all the batteries, but actually, practically, only 3 or 4 batteries would have gone bad. But what happened? Customer is replacing the entire battery, and instead of only 3 or 4 batteries, because that is a fixed battery management topology earlier. The 40 blocks, the system will work with 40 blocks only. We cannot remove 4 or 5 batteries from there. If we remove 4 or 5 batteries, inverter, the DC voltage will not be met by inverter. So that is a mandatory it is going to be. Wherein here, flexible battery management, it's giving a wide window, wide options it's giving. So in that case, it will, one sec. In this case, it's giving a wide options it's giving for the bandwidth. Even 40 blocks, there are say 8 battery has gone bad. That 8 batteries can be removed. System can work with 32 batteries, available batteries. It's having a booster inside. Whatever the DC voltage loss, it will boost and it will give the inverter. So we need to specify about whether this topology is flexible battery management or not. So overall, if you consider the commercial offer, 35% to 40%, 35 to 40% is the battery cost only. With this flexible battery management concept, huge money can be saved in front of OPEX, operational expenses. Actually, the battery life can be 5 years, more than 5 years. With this topology, the battery can be replaced only one time in the lifetime of UPS systems, say 10 years. Otherwise, what happens? 3 times needs to be replaced. So this flexible battery management, it's available in all the technologies. Need to specify about this. And this is voltage frequency independent, of course, even irrespective of input voltage, whatever our frequency, it is independent. Output side is whatever we are going to fix, that is going to be delivered. And already this has been highlighted, unity of power factor, and the compact size it is, and the input power factor will be a 0.99. Maintenance bypass, everything will be built in. It's a very compact and less weight. This is how it's going to be. The front to top airflow. Here you can see the picture. All the critical components, say thyristor block, MCBs, and the PCBA, all the components has been placed in the front side of the UPS systems, and it's covered with the metal sheet. It has been covered with the metal sheet. And if any problem comes, engineer can remove this metal sheet and fix the problem and close it. None of the component has been placed in the rear side. All the components has been placed in the front side and easy for access. And another one main important, the air exit is top. So UPS can be kept close to the wall. It's a big money saving on account of space and front service, as well as unity of power factor, transformer list topology. And another one point is flexible battery management. That is another one main important. Just we need a space to open the door on the front side. And it can come with the various configurations, standalone as well as parallel redundant configurations can be. Coming to the modular UPS. Here the modular UPS systems, here you can see that there are a number of slices. in number of slices. There are multiple modular rating is available. Multiple modular rating, the small rating, say 10 kilowatt and 20 kilowatt, and 40 kilowatt modules, as well as 100 kilowatt modules. Okay. The modular UPS, once again, I would like to highlight this. The modular UPS meant for scalability. As and when required, you can increase the UPS capacity. No need to go for a higher capacity from the day one. Just for example, you are now the current load is say only 100 kilowatt, and future load is going to be a 400 kilowatt. The client can choose the frame 400 kilowatt frame. Inside UPS modules depends on the load requirement. 100 or 200, they can buy particular modules. So in that case, what happened? Energy saving is a huge. Instead of 400 kilowatt, client is using only 200 kilowatt. So 50%, with a 50% load, the efficiency will be very, very poor. So it is all in our hand how to manage the efficiency. Any electronic components will give the better efficiency unless the load is at least minimum 75%. So wherein here the UPS capacity is in our control. What rating they need to buy, okay, what frame size is required. ELA, what happened? The worrying part is the approval, capex approval. So that's the reason that they are going from the day one the higher KVA rating. Okay, but now with this topology, they can, when the load is getting increased, they can buy a UPS module, upgrade it, scale it without that too, without any shutdown of the critical load. That is the main thing. Cannot think about any kind of shutdown. No need of shutdown of UPS systems, or no need to drop the load, or no need to transfer the load to the bypass. Without that, the modular UPS can be possible. That is possible with the true modular UPS concept. There are two concepts available in the market. It is a semi-modular and true modular. Semi-modular, it's a challenge. I'll tell you, semi-modular, it's a challenge. It may not be possible. But a true modular UPS, it is possible for upgrading the UPS capacity without any shutdown, as well to fix the problem. If any modules are problem, to fix the problem, no need to shut down the load, no need to shut down the UPS systems, either no need to transfer the load to the bypass. Without doing that, in online, that faulty module can be swapped. That is the main purpose for the going for the modular. Modular UPS, scalability, serviceability, and easy maintenance. That's the main purpose. Here in the picture, you can see that there are various ratings. There are various ratings are available. It starts from 10 kilowatt, 20 kilowatt, and 40 kilowatt and 100 kilowatt modules. So, as I mentioned, there are two architecture in the market. One is a semi-modular, and another one is true modular. What is semi-modular? Here you can see this, all the things, boxes, all small boxes. These all put it in the one frame. All the boxes put it in the one frame. In this case, you can see that the power unit, rectifier, inverter, that's the power. It's called a power unit. These all multiple units. Say just for example, now customer load is 80 kilowatt. There are 40 kilowatt module has been provided. 3 power units of 40 kilowatt has been provided. System logic is only one. In the frame, this all is going to be assembled in one frame. It will not come in the separate box. It will be in only one single frame. It will be. System logic also will be one box. There are 3 power unit boxes. Static bypass is again only one box. Control panel will be molded in the frame. Battery bank, anyway, it's external. This is how the architecture looks. It's typical. It looks like a rack mount or modular concept. But practically, if you ask me, the redundancy level is missing here. The redundant level, it's available only the power unit side. Only the power unit side, not in the system logic. System logic is a main intelligent module. It's a main intelligent module, and otherwise I would say it's a CPU. Okay, and there is no redundancy here. Control panel, again there is no redundancy. Static bypass, again it's a common, no redundancy. Even if any one of this power unit fail, say 80 kilowatt is the load, so 3 numbers of 40 kilowatt power unit has been given. If any one of this power unit fails, the other 2 power unit is going to support to the load. What will happen if system logic fails? That is, intelligent module fails. The entire thing will drop. The load will drop. So no redundancy. Again, bypass. If bypass fails, again no redundancy. If two units are failed here, it's automatically load will go to the bypass. Again, the bypass is a single component. Again, there is no redundancy. Control panel is only one control panel. If it's any problem in the control panel, you cannot monitor what is the status, what is going on inside the UPS system, what type of load it is handling, what percentage of load it's handling. No clue. Again, there are chances for the single point of failure. This is called the master slave configuration. This is nothing else. It's a master slave configuration. This is only the master. This is the master. The rest all slave. Okay. If slave fails, this fails, not a problem. There is the master will now control other modules to support the load. But if master fails, and everything will off. It's called a centralized parallel architecture. In other way, we can say it's a semi-modular UPS architecture. Okay. Master slave configuration. What is the right technology in the modular? Full redundancy of all critical functions at module level. How it's going to be? Okay, highest system availability in the market. This is the module. You can see this is a complete UPS module. It's a complete UPS module. Each UPS module is having a rectifier, inverter, battery charger, system logic, so static switch, control panel, separate battery connections, everything. It's a complete UPS module. And this is how the architecture will be. Now, again, the same concept. Okay. The technology, this technology, again, it's a three numbers of 40 kilowatt to support 80 kilowatt load. Here you can say each module is having their own components. Each module is having a own components, control panel, logic, rectifier, inverter, static bypass, as well as the battery. Battery also it is possible for the common as well as the individual. It depends on the space availability and the budget of the customer. But module wise, it's a true modular. It's a true modular, no common components, no single point of failure. Even if any problem, this model, say system logic, if anything's failed, this particular module will not be in service. Another two module which is going to support to the load. And each module is having a control panel. Each module is having a control panel with switches. This is another one big advantages in this technology. So what happened? Additional to the future of modular UPS, as I mentioned earlier, modular is having a future of scalability as and when required, serviceability, quick service support, and another one step is how quickly, how friendly it is supports. It's a DPA control panel. Each UPS is having their own control panel and switches. With this technology, customer no need to worry about the service support. They can keep some spares module at their site, and first level training can be given to their facility team. They don't need to depend on trained engineers to fix a problem. The facility team, even if any problem comes, the facility team, they can swap the module. They can swap the module. Let's call a friendly concept it is. The particular module they can shut down and swap with the spare module. No need to go for any kind of shutdown, no need of any kind of expertise to fix the problem. That is the main purpose for going for the modular UPSs. The customer is paying a huge money on modular UPS. They should get all these facilities. Okay. This is called a decentralized parallel architecture. This is called a multi-master configurations, not a master slave configuration, which is a multi-master configurations. So limited spare parts inventory in quantities, just when only one module they can keep it, depends on their capacity, UPS capacity, what they are using it for the spare, for the service support. Just they can swap it. Here you can say each module is having the controller, display, and everything. Just hard swapping, no need of shutdown. Right? So just I would like to know, share you one video. It will give more clarity about this.
Many organizations today depend entirely on their ICT equipment's continuous availability to stay in business. However, while demanding better protection than ever from their UPS or interruptible power supply systems, users face unprecedented constraints on their budgets, as well as environmental pressure to go green. Modular UPS topology is becoming the answer for ICT, or information and communications technology operators, facing these pressures, and is currently the fastest growing segment of the three-phase UPS market. There are primarily three advantages why an organization would benefit from a modular UPS system: availability, scalability, and efficiency. The majority of modular three-phase UPS systems currently available are centralized systems. Centralized means that components are shared by the individual modules within the system. UPS systems based on decentralized parallel architecture, or DPA, do not share any common components. DPA means that each UPS module contains all the hardware and software required for full system operation. Potential single points of failure are eliminated, and power availability is maximized. Each UPS module has an independent static switch, rectifier, inverter, logic control, control panel, and battery configuration. System availability is further maximized by the true safe swap modularity of the modules. True safe swap modularity enables the safe removal or insertion of UPS modules without risk to the critical load, and without the need to either transfer the critical load onto raw mains or remove power from the critical load. If an engineer comes to identify a problem, they can then see which module is defective and replace it with another module. The modules are built in a vertical rack so that they can be easily removed and no rear access is required. With a non-modular UPS system, the mean time to repair could be several hours or more, whereas with a true safe swap modular UPS, the mean time to repair is determined by how long it takes to replace a module, which typically is 15 minutes. A UPS system's ability to grow as the size of its load changes is referred to as its scalability or future-proofing. Traditionally, future-proofing of a UPS installation meant installing a UPS that is much larger than today's load, in an attempt to ensure there is sufficient capacity to meet the anticipated future load requirements. The two major drawbacks of this approach are the heavy upfront capital investment requirements and the fact that the large UPS will be wasting significant amounts of electrical energy by operating inefficiently. Modern modular rack-mountable UPS systems eliminate the disadvantages of the large system approach, since the UPS system can be scaled in one of two ways, either vertically or horizontally. This right sizing reduces initial cost, optimizes operating efficiency, reduces floor space requirements, and helps decrease total cost of ownership. This picture shows an example of a typical vertically scalable UPS system. In this example, a UPS system cabinet capable of housing up to 6 UPS modules initially contains 5 UPS modules. The 6th slot is left empty. If the critical load increases above the installed UPS power, then an additional UPS module could be added to the cabinet. Horizontal scalability is used if additional capacity or redundancy is needed. Independent UPS systems can operate in parallel configuration, achieving the required power capacity. The optimum parallel UPS solution is only achieved with systems that provide a true, safe swap, scalable, and modular architecture. True modular parallel UPS solutions enable organizations to simply and cost-effectively expand their UPS system's power and availability. The result is improved efficiency, lower cost of ownership, and better customer service through high availability.
Yeah, that's the modular UPS concept. That's all from my side. If you have any questions, clarifications, I'd like to take it up.
Thank you, sir, for that session. We have one question. Which technology, CPA or DPA, is better for server critical loads?
It's always, I would recommend the DPA architecture. That is a decentralized parallel architecture, where the critical load, when I'm saying the load itself is a critical load, none of the load, because when their customer is using a UPS, they are buying a UPS systems to protect the critical load. So the decentralized DPA architecture always better to protect the load, so that the load will not drop at any point of time. It's having a redundancy inside.
Okay. The next question is, can you share some insights into the types of battery which goes into these UPS system, like the sealed lead acid, SLA, the flooded type, or the lithium ion, which is best recommended for applications such as data center?
It is there are two architectures available now. Sealed SLA, that is VRLA batteries, sealed maintenance free batteries, VRLA batteries, and also lithium ion. Lithium ion battery also now, it's the latest technologies available in the market, which is having a now better life cycle than VRLA batteries. It comes with 8 to 10 years life cycle, where in the VRLA battery it comes with a 5 years life cycle. The UPS meant for the 10 years, 10 to 12 years. 10 to 12 years the life cycle of the UPS systems. And the lithium-ion battery, it is a latest technology, and it has been promoted by most of the supplier. But anyway, it's VRLA has been proven. VRLA has been proven, and which is working already. VRLA is proven, and it is working 4 to 5 years. This is lithium-ion. Yes, it's in the paper. I hope that will work. It's 10 years. Both is compatible with data center loads.
Okay. Can you throw some light on sealed lead acid? What is sealed lead acid batteries?
Sealed lead acid, again, it's a new concept. It's a new it has come to the market. It is a proven. It is this all there are now lot of battery topologies are coming for their market. This is they yet to explore.
Okay. Can modular UPS be used for regenerative power loads?
Yes, of course, of course. The load is we have to see what type of regenerative load, whether it is regenerative, what percentage level it is. Whether it is we need to oversize the UPS capacity, or the same capacity we can run. It is UPS is meant for all the rate, all the load, all the type of loads. We need to be choose the right architecture, whether the transformer is mandatory or without transformer the load can be run. That we need to choose.
Okay. Please elaborate on the battery management capability.
Battery management, there are two type of battery management. One is individual battery monitoring, and another one is bank monitoring. The bank monitoring, mostly all the UPS suppliers by default, they have the software. So no need to have a additional cost for this. Just we need to ask the UPS supplier to enable that software and this which is available in the UPS systems. In that case, just you need to program it, whether once in a month or 2 months, now twice in a month, battery needs to be checked, or how it's going to be. That periodical check is available. And another one is block monitoring. Block monitoring is an individual block monitoring. It is not a bank monitoring. If UPS is connected with 100 batteries, that bank monitoring, the block monitor is going to monitor each individual cell about the resistance and the impedance, everything, and it will give a report. That's a totally different concept. So two monitoring, one is a block monitoring and another one is bank monitoring.
Okay. Can you, one second. How much is the heat dissipation in modular UPS compared to other UPS?
The modular UPS, neither conventional UPS, whatever, that heat dissipation, it depends on the connected percentage of load. If percentage of connected load is even the modular UPS is less, again, it's going to be the same efficiency. But only the thing is here we can control the efficiency in modular UPS. For example, now the customer is purchased a 200 kVA UPS systems, but the running load is only 80 kilowatt or 100 kilowatt. What they can do, they can shut down the two modules or three modules, and they can optimize the UPS capacity to run the load, to save the load. Wherein the conventional UPS systems, it is not possible. It's a single module. If the customer is buying a 200 kilowatt UPS systems and the load is only 80 kilowatt or 100 kilowatt, he cannot shut down the 100 kilowatt. It's a single module. So in that case, the percentage of load is only 50%. The efficiency will come down to 92%. So irrespective of modular or conventional, we need to choose the right capacity to optimize the efficiency.
Okay. How to size modular UPS for server loads typically?
The server load, certainly it's having each server load having a capacity. What type of, how many servers, how many racks are there? The calculations can be shared with the UPS supplier, and UPS supplier can design the UPS rating accordingly.
Okay. Isolation transformer is really required for IT loads. Will you suggest to go with it?
It is not mandatory, ask me, because the isolation transformer earlier, what happened 2 decades back, it's not isolation transformer based UPS systems. It's the transformer has been used for mainly for the step up the voltage, not for the isolations. Most of the technology 2 decades back, the DC voltage was less, 240 volt DC or 360 volt DC, while conversion that will come down, the output voltage will come down to 300 volt or less than 300 volt. Output voltage, required output voltage is 415 volt. To step up the voltage, to meet the voltage, the transformer has been connected. Then there is, they said it's isolation also there. Okay. But at the same time, now with the booster technology, what I have highlighted is it's having a booster technology. And with the booster technology, with the EDCP filter, electronic, it's having an electronic DC protection filter at the output side of the UPS systems. So the isolation transformer is not mandatory. I'm not saying that it is not for all the loads. We need to see the type of load and how the distance between the load to UPS system, that also need to check. But most of the IT side, I can see the IT racks also having an isolation transformer. So keeping the two transformer may not be mandatory. Transformer at UPS and transformer at IT racks may not be mandatory. This.
Okay, sir. Can you give some details on transient or inrush current capacity?
Transient and inrush current capacity, it depends on the connector load, actually. Okay. And it is not applicable to all the load. Okay, it depends on the connector load. The industrial load, industrial current may be a different, IT loads is a different. You need to see the data sheet of the connector load. But the UPS is having a 1.25%.
Okay. Price difference between DPA and CPA?
It is closely 30 to 35%, because what happened, there are many components is missing in CPA architecture. So certainly the price wise it will be cheaper than DPA. At least 30 to 35% will be cheaper.
Okay. Flexible battery management booster works for how many hours?
Flexible battery management. See, the flexible battery management is totally different. What I'm saying is, with the flexible battery management, you can save the money on account of operational expenses, OPEX. Because in the fixed battery management, just 1 second, I would love to highlight on this. When it's a fixed battery, suppose if any of the UPS systems, it comes with 40 blocks. If you remove 3 or 4 battery, system will not work, because the design is like that. It need a 480 volt DC. System cannot work with 360 volt DC. System will need a 480 volt DC minimum. So in that case, even if the batteries are going bad, the customer is replacing only the faulty battery with a new battery. Assume that faulty battery with the new battery. In that case, what happened? The batteries are already old battery, 3 years or 4 year old battery, because the battery, as I mentioned, it is a 3 to 4 years. After 3 to 4 years, only the problem is going to come. So the available batteries are already used. The lead content inside already it has gone weakened. So what happened? Now out of 40 batteries, say 36 batteries are new, 36 batteries are old, and 4 batteries are new. So the 4 batteries having a strong lead content, and 36 batteries having a poor lead content. So while charging and discharging, it will not be equalized. So these 4 batteries, new batteries will kill the other batteries. So slowly they are going to replace all the batteries. Every month the customer may replace because of this charging, the discharging not equalized. It is going to replace all the batteries. They will replace all the batteries within a couple of say 3 to 4 months down the line. That's the reason customer made a standard practice, replace their battery with the flexible battery management. Now the 40 blocks has been given. 4 battery has gone bad. Remove the 4 batteries. System will work with 36 batteries. Like that, the technology is available up to 20%. You can remove the batteries. If it is say 40 block systems, you can remove 8 batteries. System will work with the 32 blocks. If it is a 50 block systems, remove 10 battery. System will work with 40 block systems. It's a big money saving on account of operational expenses, especially.
Okay. It is single path for incomer, outgoing cable and breaker. Single point of failure will be outside UPS level in modular UPS design.
No, actually, what happened? Even if you are going for a conventional UPS systems, the conventional UPS systems, again, it's going to be parallel in one box. From parallel, again, it's again single cable. The same questions arise in one conventional UPS also. So the modular UPS, what happened? The big benefit the modular UPS, input, output paralleling, everything is happening inside the UPS systems. In conventional UPS, in physically, the panel is available output side, on the output, on the other box, not in the inside of the box. Here also the same thing can happen. Finally, when we are paralleling two UPS system and taking the single cable. So the modular UPS gone for all the tests, and as of now, we have not any, even all the suppliers, they have not seen any kind of failure on the cable side.
Okay. If faulty batteries are removed, battery backup will be affected.
Of course, say it's a good question. It is, say when it is removing from 40 blocks, from 40 blocks you are removing a 10 blocks, the autonomy time will come down. Autonomy time, instead of, say, if customer is buying a 15 minutes backup, it will come down to 12 minutes backup. So while choosing the flexible battery management, customer can ask whether they want to go with the 15 minutes backup from the day one or 18 minutes backup from the day one. If they are giving additional money for 3 minutes backup, where they can save huge money, even the 3 battery has been removed, but still the autonomy time has been maintained. But most of the cases now, the generators are connected with the backup of UPS systems. Within a minute, the generator is going to come into the picture. So the 3 minutes will not have a big impact, as per my knowledge.
Okay. What about harmonic filters? I think this question might be with regard to the harmonics.
The harmonics, now the technology has been very much improvised. There is no additional harmonic filter required in any of the technology. If they are going to provide a thyristor-based rectifier, then yes, there is a harmonic filter is mandatory. But most of the supplier now moving towards the better technology with IGBT-based rectifier. Now, some of the suppliers having IGBT, some of the suppliers having IGBT with diode technology. So the harmonics is very much controlled here.
Okay. The modulars need to be manually switched off or on if the load is lesser than designed.
There are two architectures available. There are both options available. One is automatically it will go to the sleep mode. Say now the customer has purchased a 200 kilowatt UPS and the load is only 80 kilowatt. Two or three modes automatically will go to the sleep mode. No need of manual intervention. Depends on the load, it will wake up again. And some of the technology, yes, it's manual need to be. Both option is available.
Okay. Is it mandatory to provide double the size of power cable for neutral in modular UPS too?
Yes, it has to be.
Yes, sir. I think we are done with all the questions. I will now request Mr. Arvind Shastri to please take us through the benefits of ISHRE membership and share the vote of thanks.
Yeah. Before I start, actually, I'm Arvind from ISHRE membership team, and then let me tell you a couple of now the benefits of getting into a membership of ISHRE. So, what are the benefits which we can think? We can able to get into a such kind of a good programs which is continuously happening in and around the entire India, where you will be accessible for all the programs which is useful for your all your day-to-day activities and also for enhancing your technologies. And also, you will be accessible to get publications which is published by the most of the industry specialists, and you can access the most of the standards books which we can be able to refer to for our designs and then other requirements. And also, you will have a benefit of networking with all the good consultants across the India, and you will definitely get to have exposure to a new latest trends in the HVAC industry and also in the upcoming building segments. So nevertheless, I think we have different divisions in that. Actually, we have a youth, we have a students division, we have professionals divisions where we can be able to get enrolled into. And I would suggest those who are interested to become a member, you can just put it in the chat box that our team will get back to you. Mr. Girish from the admin team will be able to talk to you directly and then explain you still more better on the benefits of being a member for ISHRE. And nevertheless, and actually the fees for the entire 3 years is 8,850 rupees inclusive of taxes. So roughly around about 2,000 rupees odd for a year. So my request to you to just look into it and then make a early entry into to the membership so that you get all the benefits for yourself. Thank you very much. And then I would like to thank Ashok sir. It's a wonderful event, and then I think we could able to get a lot of insights onto the latest trends in the modular UPS technologies. And then I would really give you a lot of thanks for giving a lot of understanding on the technology. Also, answering is so ease and grace, irrespective of the whatever the questions people have put it. And then it's so amazing to get all the knowledge from your end to all of us. Thank you very much, sir. Thanks for giving us a lot of knowledge on the new trends in the UPS industry. Thank you very much. And thank you all the people who have attended the program. And then we look forward for you for upcoming programs as well. Thank you very much. Thank you one and all. Good day. Take care.
Thank you
Stay
so
healthy
much.
and stay safe. Yeah.
Thank you, everybody. Stay safe.